very shortly. I will try to keep it short. Let's move on. Yeah, this is about the recent training activity. Last time I was silent, so I realized that this time I badly need to report on our activities. So in the 2024-2025, following the agreement with NMHSs in Belarus, Kazakhstan, and Ghana, Russia CoE got governmental grant to offer online professional development programs for employees of these weather services. And so we ran a BPM weather forecast course in Russian in 2025 with 28 people enrolled from Belarus, Russia, and Kazakhstan, and 22 people completed. That was 78% completion rate. Then we had the same course ran in English with 44 employees of Ghana Weather Service enrolled and 37 completed. So it was higher than that. It was 84% completion rate. And we also ran a shorter course, which was called Satellite Meteorology and Global Climate. Sorry, we have, I've lost the, yeah, thank you. With 17 people enrolled and only 4 people completed. It's written it's all from Russia, but this is not true. We had also participants from Belarus and Kazakhstan. It was in Russian. I don't know why this shorter course was not as well perceived as the other one. Maybe people who enrolled to this course thought that since it is shorter, then it is simpler. It wasn't. Right at the moment, we have 9 people enrolled in BPM course this year in Russian, and the next year we are offering it again in Russian and English. We have another agreement with Ghana Weather Service, and this is the example from thesis defense or final paper defense. Next slide, please. Yeah, so the BPM course, which was quite successful, had 5 thematic modules following the BPM structure: physical meteorology, dynamic meteorology and numerical weather prediction, weather services, climate services, and the heat of our course was professional development module with management skills, communication skills, IT skills, and research skills. In total, it was 810 hours with 356 hours of lectures, 144 hours of practical sessions, and the rest was self-study. And the course paper, of course. And so, as I said, it was delivered in Russian last year, this year, and the next year there will be a second run in English. Next slide, please. Another recent training activity was that Russia CoE and VLab Russia have developed AI-assisted learning across 3 distinct course formats during this academic year. And the first was a full BSc module on artificial intelligence systems offered for second-year students who have not completed yet enough math. So there was some question, what shall we do with this planning? But in the end, it ended up well. So we offered this for 40 full-time second-year students. Then there was a condensed version for part-time learners, and recently a professional development module focused on climate change problem solving also used some AI assisted learning. Next slide, please. All 3 implementations used LMS-based assignment submission. Students uploaded Google Colab notebooks with their working code and also prompt text in the Markdown session. And success was measured by task completion rate, also code quality, and observable growth in student confidence. Results fed directly into iterative redesign between course editions. So we started from a simple course for BSc and ended up with suggestions for professional development course. Next slide, please. So the common thread across all three courses, students used AI coding assistants such as ChatGPT, GigaChat, DeepSeek, Claude. We have a Google Doc with neural options available. Whatever we could find, we put it there. So to write, all that was used to write Python programs for data processing, progressing from simple to complex. And Google Colab served as the unified computing environment, removing any installation barrier. Next slide. So the first assignment was identical in all implementations, and we call it, so it was a kind of deliberate confidence builder. Students choose any AI assistant and asked to write a Python program to retrieve current weather data for St. Petersburg using the OpenMeteor free API with no key required. And then the Meteostat library for recent station data. And finally, the Copernicus climate data store with a pre-issued API key to retrieve weather on their birthday in the historical past. So students submitted their prompt together with the working notebook, which make the prompting process itself part of the assignment, the assessment. Next slide, please. Yeah, so here you can see the three detailed prompts students used. Prompt A for OpenMeteor, entry level. No registration needed. Prompt B for Meteostat adds library installation and station discovery. And prompt C needs pre-issued API key, which you can keep in Google Colab secret area. And also it introduces NetCDF processing with XRA, providing a first encounter with reanalysis data. And all three prompts are fully self-contained and reproducible. So I suggest you to try any of these yourself, and you will see the result. And this is really impressive for students who have never done any programming. And next slide, please. In the full BSc module, assignment 1 opened 8 progressive themes. Students moved from API chats and raster imagery to Sentinel-2 satellite scenes and NDVI calculations, then to connecting a neural network by API directly, practicing prompt engineering, applying machine learning to ERA 5 time series, by using clustering weather types with k-means and processing MODIS aerosol data, drawing aerological diagrams with MetPy, another Python library. So that was the BSc module. Next slide, please. For professional development module, for climate course, the same AI-assisted approach was adopted to climatological tasks. And assignment P2 retrieves Aero 5 temperature series, plots trends against assessment report 6 references. Then we computed climate indices for extreme events. And then Aero 5 seasonal composites and difference maps were to explore El Nino Southern Oscillation variability. And we ended up with the practical task 5 to compare SSP scenarios to 2100, given practitioners hands-on experience with the tools they need for operational climate services. Next slide, please. So these are the key outcomes across all three implementations. Assignment 1 achieved over 95% completion. That was a huge success, giving students who have never done any programming the feeling that they could handle data processing with this tool. AI assistant absorbed the routine API code, freeing students to focus on interpretation. And submitting the prompt created some reflective practice. The main challenge were often changing parameters of API because the large language models were trained in the past, and so usually when you ask uh, now to do some task, and like for example, DeepSeek thinks it's still 2024. So there were some challenges which needed some help from the teacher. Um, But this can be addressed through various LLMs and shared prompt templates. And the next steps will be to build a shared meteorological prompt library with simple tasks also in satellite meteorology domain. Develop a BIP align rubric for AI assisted assignments and pilot the approach at partner VLAP institutions. So I invite you to follow this example or experience. And big thank you to Marcial and Diego for introducing me to GeoVibe coding at VLMG 11 in Muscat. Thank you very much. That's it.